Hey guys, since the quiz is coming up soon and we probably won't have the time for a full tutorial, I just want to make a couple of walkthroughs for some of the questions in the sample quiz. So this first video is specifically for the first problem. We'll go through the general algorithm that will help you solve the problem, as well as a couple of samples. So yeah, let's see how it goes. So for the first problem, you have to complete four basic steps. First one is basically you're going to be given two functions, right? And then you're going to have to combine them in some particular way. So the first two steps are to define the domain of f and domain of g separately, right? So you take these two functions, you simplify if you can, and then you find the domain of each one separately. And then once you have the separate domains, it's actually pretty easy to find the domain of their product or their quotient. So here are the two formulas that you need to remember. If they're asking for the domain of the product of the functions, that is just the intersection of the two domains that you already found. Of course, I'm going to give an example soon. And then if you're required to find the domain of the quotient of the functions, then it's almost the same thing. Like the first part is the same, as you can see, but from that intersection, you need to exclude the point or points for which g equals 0. Now, I know this probably sounds too abstract and it's probably not too clear, but again, I'm going to give examples. I'm going to solve actual problems in a bit. These are just like the general formulas that you can use. It's only two formulas, so it's easy to remember. And it's not even like a formula, it's just like an intersection. So let's take a look at an example. This is, I believe, the first problem from the samples. So we're given f of x equals square root of minus x squared plus 4. And then g of x is equal to x cubed plus 2x. So again, first two steps are to simplify and then find the domains of each one. Can we simplify this first function? Well, let's see if we can do anything under the radical. First thing, I don't really like square roots with a minus in front, so I would just like swap the places of these. And then once I have it in this form, I can recognize that this is basically the difference of squares, right? This can be rewritten as 2 squared minus x squared. And that in hand can be rewritten as 2 minus x times 2 plus x. Now, I'm not explaining this in great detail because, like, I believe you already know it. In case you don't really understand what's going on here, you can just check out the difference of squares formula, because that is basically a high school prerequisite. And of course, if you still don't understand something, just let me know and I'll help. But this is like the first step. And then can we simplify this? Well, not really. There isn't much we could do. We could potentially take an x out and do like x squared plus 2, but it doesn't really make much sense. We don't really need it in this case, so we can just leave it at that. And now we need to figure out the domains. So if we try to figure out the domain of f, what is it gonna be? So this is our final expression for f. Now, here we have a radical, or like a square root. And whenever we have a square root, or any root with an even degree, right, 4th, 6th, 8th, 10th root, etc., the expression inside the root needs to be greater than or equal to 0. Otherwise, it's not defined, at least not in the real numbers. So I'm just going to copy the expression inside. 2 minus x, 2 minus x times 2 plus x needs to be greater than or equal to 0. And now there are multiple approaches to solving this. The way I do it is the following. I just draw a number line because it helps me visualize everything. And just for a brief second, I ignore this sign and I treat this as an equation, as the equation 2 minus x times 2 plus x equals 0. So I'm basically asking myself, at which points does this thing equal 0? And now that's again just high school material. One of the roots in this case is 2, the other one is minus 2, right? Because if you plug in x equals 2, then you're going to have 2 minus 2, which is 0, times 4, which ultimately gives us 0. Or if you were to flip it and use x equals minus 2, then here you would have 2 minus minus 2, which is 4, 2 plus 2, 4, times 2 minus 2, which is 0, and again gives us 0. So 2 and minus 2 are the roots of this equation, temporarily an equation. And I'm just gonna draw them here on the line, minus 2 and 2. By the way, your line doesn't have to be particularly precise. You could put them wherever you want. And now, once I'm done with this, I will go back to the inequality. And now, in order to determine which zone gives me a positive sign and which zone gives me a negative sign, I typically just test with some easy value of x. So for example, if I pick, so by the way, these are the 3 intervals, right? 3 distinct intervals. And typically the signs alternate. So it's either like minus, plus, minus, or plus, minus, plus. I hope you get the hang of it. But in order to know exactly where we have a plus and where we have a minus, what I do is I just pick a random value in one particular interval. For example, if I use x equals 0, which is in this interval here, I just plug it into this expression and I see if the result comes out greater than 0 or less than 0. So if I plug in 0, I get 2 minus 0 times 2 plus 0, which is equal to 2 times 2, which is 4, and it's definitely greater than 0, right? And what does this mean? This basically means that in this interval where I took the value, we have a plus sign. Therefore, the intervals on the left and right are going to be with a minus sign. And because here we actually care about when this is greater than or equal to 0, the valid domain would be this one, right? The one where I have the plus thingy. So for f, the domain of f is x between minus 2 and 2, like this. By the way, if we didn't have the equal sign here, we would have it like this, a closed interval. But now it's an open interval. Wait, is it the other way around? I don't actually remember the terminology, but anyway, you saw how it's written. Okay, we have this for f, and now we need to find the domain of g of x. We're really lucky here because this is defined over O values. Like there is no value for which this is not going to work, basically. So we don't need to do any calculations. You just need to be careful for when you have, for example, square roots or radicals. But in this case, or like fractions, because in fractions there's tricky parts too. But this has no fractions, no radicals whatsoever. So the answer to this one, let me just write it below the other one. So D, or maybe here, D of G is just all real numbers, okay? Like this. All right. So we're done with the first 2 steps. These are completed. Now we need to move on to step number 3, which is the actual question on the quiz, right? The first question on the quiz, this is point A, is find the product, the dot product of f and g, and then find the domain of that product. So for the product itself, it's extremely easy. You just multiply the 2 like functions. So that's your f, right? So you have, I'll just use the simplified version that I had here, but you don't even need, actually, I mean, it doesn't really matter. You can use whichever one you prefer. I could even use the original version. Square root of minus x squared plus 4 times, and then I plug in the other function, which is x cubed plus 2x. X cubed plus 2x. Use nice parentheses, of course. And that's pretty much it. In some cases, you will be able to simplify the product, but most of the time, you just really write these 2 things next to one another and you're done with the product. So this is like an easy points, right? And then the domain isn't really much more difficult. I already gave you the formula. So the domain of the product is basically the intersection of the domain of f and the domain of g. Now, what does an intersection mean? I typically use the number line again. And I just draw the 2 domains with different colors. So first one was between minus 2 and 2, right? So let's say minus 2 is here, 2 is here. That's my first domain. And then for the second domain, for the second function, it was basically all values. It's basically the whole thing here, from minus infinity to infinity. So where do these two intersect? Where do they overlap? Well, they obviously overlap in this section, right? Between minus 2 and 2. And from here, I can directly say d of f times g equals minus 2, 2, 2, like that. Okay, now b. It's similar, it's very similar. We start nearly the same way, f divided by g. Was that the question? Yes, f divided by g. So again, for f, you just take the value of the function and you just write it down. So that's square root of minus x squared plus 4 divided by, and then for g, same thing. You just go back to the original question and you just copy this thing, x cubed plus 2x. And again, there isn't much more that you can do, so you don't even need to try to simplify this. That's your answer for f divided by g. And then for the domain, it's gonna be very similar to the domain of the product. So we're gonna start the same way, which is d of f intersected with d of g, which we already found, by the way. This is the answer to that portion. But there's one addition here, and that is that from this thing, we need to basically remove the values for which g equals 0. Why, by the way? Well, because we're dividing by g, but the denominator can never be 0. So we can't really have g equals 0. So let's take g. That's g, right? We already have this as g. And let's see when this equals 0. So at this point, I will actually take out an x, like this. This thing equals 0. And then, again, when we have a product of two things, and we want to check when it equals 0, it's either that the first portion equals 0, or the second portion equals 0. And of course, both of them could be 0, but one of them is enough in order to make the whole result be 0. So from here, it follows that my options are either x equals 0, or x squared plus 2 equals 0, meaning x squared equals minus 2, if I bring this to the opposite side with the opposite sign. But notice how this actually doesn't have a solution, right? Because x squared, there's no number that when we square it gives us a negative value. So here we can't find any other solutions. Therefore, the only case for which g is 0 is when x equals 0. So what does that mean? This means that from our previous answer, which was minus 2 and 2, we're just gonna subtract 0, okay? So it's basically from minus 2 to 0 and from 0 to 2. But the 0 itself we don't count. You could rewrite this in another way, but I'm not gonna actually burden you with that. This is perfectly fine as your final answer for that question. Okay, I guess let's do one more. Let's see this one. It's actually quite similar, I believe, but let's just practice the whole algorithm once again. So we're given f of x equals square root of minus x squared plus 4x. That's the same as the previous one, isn't it? Oh, it's a little bit different, okay. And then g of x equals fourth root of 1 minus x. Okay, so let's start by simplifying. Let's check if we can simplify this. Well, firstly, again, I don't really like having a negative term at the front, so I would swap the places of these two. It would be 4x minus x squared, like that. And then again, I can take out one x at the front, and then once I take out an x at the front, I'm left with like 4 minus x, because one x is at the front already. Okay. And I don't think I can simplify this further, right? Let's see if we can simplify g of x. Well, not really. There isn't much we can do here, so that's pretty much it, I guess. What's the next step? Next step is find the domains of the separate functions. So, d of f, we're taking a look at this one first. And as I mentioned, whenever we have an even root, like in this case we have a second root, the thing under the radical has to be greater than or equal to 0, meaning x times 4 minus x needs to be greater than or equal to 0. And now I'll just apply the same method as I showed you earlier. For a brief second, just for a brief second, I will consider this to be an equality instead. So if we try to solve the equation x times 4 minus x equals 0, either x has to be 0 or x has to be 4. Why 4? Because if x is 4, we're going to have 4 minus 4, which gives us, guess what? 0. Okay? So these are the two roots here. And now I'm going back to the inequality, and I'm trying to figure out which of these has a positive or a negative sign. It could be like that, or it could be the other way around, right? I'm not too sure. So let's try to figure out which of these ranges have the different signs. As I mentioned, to me, it's easiest to just take a random value within one of the intervals. For example, in this interval, I could take 1. 1 is definitely between 0 and 4, right? And I could just plug it in. So 1 times 4 minus 1 equals 1 times 3 equals 3. This is definitely positive, which means that this middle interval will have a positive sign, and then the other two on the side have a negative sign. And because we care about greater than or equal to 0, this means we care about the positives. Therefore, the solution, or like the domain of f, is going to be this middle interval. So for d of f, we have x between 0 and 4. Okay, perfect. Now we need to find the domain of the g. So let's see what the g looks like. D of g. We have fourth root of 1 minus x. Again, because this is an even root, we need to make sure that the expression inside is greater than or equal to 0. This is an easier one, by the way. 1 minus x greater than or equal to 0. Now we could just bring the 1 to the other side with the opposite sign. So we have minus x greater than or equal to minus 1. And be very, very careful. This is a silly mistake that a lot of us do. But when you multiply by minus 1 both sides of an equation, the sign changes direction. Okay, that's really important to remember. Whenever you multiply or divide by minus 1 or whatever minus number it is, you need to change the direction of the sign. Okay, so that's the final domain of g of x. Or in other words, x is between, minus infinity to 1, like that. So now that we have both domains, let me actually just like highlight them. What the heck? Come on, bro. Okay, and this one as well. Now that we have both domains, we're ready to actually answer the question. So subpoint A asks for f times g. And again, you just plug in the values of the functions here. There's nothing complicated. F is this expression. You just copy it, right? So I have square root of minus x squared plus 4x, and then times, and then we have the g function, which was a fourth root of 1 minus x, if I remember correctly. Yep, there we go. And that's it. Keep in mind that when you have different degrees of the radical, you can't really like combine these two, so you just leave it at that. That's why I'm saying that these are like the easiest points to get on the quiz, because you don't even need to do much simplification. Now, for the domain of f times g, it's basically, again, as the formula said on the first page, the intersection of the two separate domains, right? So that's d of f intersected with d of g. And now, actually, I think it's easier to see it on the numerical line. So I'm just going to draw it. So for f, we had 0 through 4. So let me just draw this. Let's say 0 is here, 4 is here, and that's my f domain. For g, we had minus infinity to 1. So if we say that 1 is here, we had minus infinity to 1, like this. And now, just bear in mind, we need to find the intersection. So if we, let me just actually like draw it like that, color it in. So we now need to see where we see both colors overlapping. This part is just red, so it doesn't count. This part is just yellow, so it doesn't count. But this portion here, between 0 and 1, is the portion where the two colors overlap. And this is exactly the intersection of the domains. Therefore, the domain of f times g is equal to 0 to 1. And that's it. Okay? And then, almost done with this one, we need f divided by g. So f was square root of minus x squared plus 4x. G is fourth root of 1 minus x. And you just leave it at that. You don't need anything else for this. And as for the domain itself, as I mentioned earlier, it's similar to the domain of the product. So basically d of f intersected with d of g, but minus the point where g equals 0. So let's try to figure out where g equals 0. So g was fourth root of 1 minus x, and we need this to equal 0. That means that this thing inside has to be equal to 0. Therefore, x equals 1, right? Because 1 minus 1 gives us 0. Okay, so that value we need to exclude from our current result. So our current result from the previous step was 0 through 1 inclusive. But now we need to close the gap at 1 because we don't count the 1 anymore, right? This previous result meant that f could be exactly 1, and that's fine. But now we want to exclude the 1, and that's why I'm closing the interval early, right? This means it could go very, very close to 1, but it couldn't be exactly 1. Why? Because if x is 1, then the denominator is going to be 0, but it can't divide by 0. So, yeah, that's pretty much it. That's a general approach. If you have questions about the other, I think, 2 first problems from the samples, please just let me know and I'll be glad to help.